NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again. NASA engineers have re-established communication with the Voyager 1 spacecraft, Earth's most distant emissary, after a month of troubleshooting a glitch that had rendered the probe's transmissions unclear. What if a spacecraft launched decades ago could unveil secrets hidden at the very edge of the solar system, far beyond the reaches of our understanding? Voyager 1, currently the most distant human-made object, has done just that. It has revealed an unseen region in space that could fundamentally change the way we perceive the universe. But what exactly is this new discovery, and why does it matter? Voyager 1 has been traveling through space for over 40 years, moving further and further away from Earth into the vast expanse of interstellar space. It has already provided humanity with unprecedented views of Jupiter, Saturn, and their moons. But its most recent discovery is something entirely different. The spacecraft has now crossed into a previously unexplored region of space, the magnetic highway, where the solar wind, a constant stream of particles from the sun, meets the interstellar medium. This region is the boundary where the sun's magnetic field lines interact with those of interstellar space. For years, scientists had only theorized about such a region, unable to study it firsthand because of the vast distance and complexity. Voyager 1's new data from this region has opened up a whole new set of questions. How does the sun's influence extend into the galaxy? What role does this boundary play in the greater cosmic environment? The magnetic highway is key to understanding the solar wind's interaction with the interstellar medium, and by studying it, scientists hope to uncover answers to some of space's most profound mysteries. What lies beyond the solar system? How do cosmic forces interact over vast distances? And what can we learn about the broader structure of our galaxy? Technical challenges and achievements. Voyager 1's mission has not been without its challenges. As the spacecraft moves farther from Earth, communication becomes increasingly difficult. The signals it sends take over 22 hours to reach Earth, and because Voyager 1 is now over 15 billion miles away, the signals become faint and hard to detect. To make matters more difficult, the spacecraft is aging, and many of its systems, designed in the 1970s, are beginning to fail. Yet, despite these challenges, NASA has managed to keep Voyager 1 functional. The spacecraft has experienced a few hiccups over the years, including a mysterious switch to a backup radio transmitter, which had been inactive since 1981. Despite the weakness of the new signal, the team was able to detect it, proving that the ingenuity of the engineers on Earth continues to defy the odds. The recent switch to a lower-powered transmitter, known as the S-band, has raised concerns about how long the spacecraft can continue transmitting data. The system is aging, and power is diminishing with every passing year. However, this discovery has sparked a new appreciation for the resilience of the Voyager spacecraft. Even as the spacecraft systems are slowly shutting down, it continues to provide valuable data that will help shape our understanding of space for generations to come. What is the significance of Voyager 1's discovery of the magnetic highway? The discovery of the magnetic highway is crucial because it gives us our first real insight into how the solar wind interacts with the interstellar medium. This region is not something we've been able to study directly before. By studying it, scientists can better understand the forces that govern the boundary between our solar system and the rest of the galaxy. This discovery could also provide valuable data about cosmic radiation, magnetic fields, and the behavior of space over long distances. Knowledge that will be essential as humanity ventures farther into space. What are the challenges Voyager 1 faces in maintaining communication and sending back data? Voyager 1 is facing the challenge of increasing distance, which results in weaker signals. Additionally, the spacecraft is aging, and many of its systems are beginning to fail. Despite this, NASA's Deep Space Network has continued to receive data by relying on the spacecraft's backup systems. These challenges highlight the difficulty of long-term space missions and the ingenuity required to maintain communication with spacecraft so far from Earth. What are the implications of Voyager 1's discoveries for space exploration? Voyager 1's discoveries hold major implications for future space exploration. By studying the magnetic highway and other data from the edge of the solar system, scientists can learn more about how the solar system interacts with the greater galaxy. This data will help inform the design of future spacecraft and deep space missions, such as those aimed at exploring other star systems or even interstellar travel. As we begin to understand the significance of Voyager 1's discoveries, one question remains: what will the future of space exploration look like based on the knowledge Voyager is sending back? What new technologies, ideas, and strategies will emerge from this new data, and how will they shape humanity's future in the stars? Deeper exploration of the region discovered. When Voyager 1 crossed into interstellar space, it reached a threshold that had been the subject of scientific speculation for decades: the magnetic highway. This region, where the solar wind, propelled by the sun, meets the interstellar medium space that exists between star systems, was previously uncharted territory. Voyager data on this area provides us with the first direct measurements of the interactions that occur at this boundary, and it could reveal much more than just the makeup of space itself. The solar wind is a continuous stream of charged particles emanating from the sun, but once it reaches the edge of the solar system, its behavior changes dramatically. Here, it interacts with the magnetic field of the Milky Way galaxy, which can distort the flow of the wind. The data Voyager has gathered from this point in space offers crucial insights into how stars and their systems interact over vast distances. But the implications go beyond just understanding the structure of the solar wind. By studying this magnetic highway, scientists can gain insights into the very nature of interstellar space, uncovering secrets about cosmic radiation, magnetic fields, and even the boundaries of life-supporting environments beyond our solar system. This discovery offers us a clearer understanding of the solar system's outermost layers, but it also raises profound questions about what lies beyond. The farther Voyager 1 moves, the more it can tell us about the nature of space itself, opening doors to future research into interstellar travel and our place within the cosmos. Philosophical and scientific implications. Voyager 1's data has sparked a deeper philosophical reflection on humanity's role in the universe. We are now able to grasp a bit of the cosmic forces that govern the space between stars, an environment previously beyond our reach. This leads to one of the most compelling questions of modern space exploration. How does this discovery change our understanding of the solar system and space as a whole? Voyager 1's journey and findings represent the very limits of our technological capability to explore and communicate across vast distances. Yet, despite these limitations, the spacecraft has uncovered something truly groundbreaking. In a very real way, the data that Voyager has sent back shows us the beginning of what could be humanity's future journey beyond the solar system. As we face the challenges of exploring distant planets or even reaching other stars, Voyager 1 provides a proof of concept for long-term space missions. It shows us that it is possible to send probes far into space, communicate with them over unimaginable distances, and gain valuable scientific data that extends our understanding of the universe. It's not just a story of technology. It's a story of persistence, ambition, and the human desire to explore. However, the discoveries raise another question. What comes next? The more we learn about the cosmos, the more we realize how little we know. Voyager's mission teaches us humility in the face of the vast, largely unexplored universe. Yet, it also reminds us of the limitless possibilities ahead. Could the data Voyager collects inform the technology needed for interstellar travel? Could it pave the way for future missions that send humans to the stars or even colonize distant worlds? These questions will shape the future of space exploration and provide us with the drive to keep pushing the boundaries of what is possible. The legacy of Voyager 1's discoveries. While Voyager 1's mission is a remarkable example of human ingenuity, there are other space endeavors that reflect the growing ambition of humanity to explore beyond our planet. Consider the Mars rovers, which have given us unprecedented views of the Martian landscape, or SpaceX's ambitious plans for Mars colonization. These modern missions draw inspiration from Voyager's long-term approach, taking humanity beyond Earth's confines, whether to study new planets or, perhaps one day, to make them habitable. Just as Voyager 1 has opened the door to interstellar exploration, so too have missions like NASA's Artemis program, which aims to return humans to the Moon and prepare for potential future missions to Mars and beyond. These modern endeavors, paired with the data Voyager is providing from the outer reaches of the solar system, will help shape the technologies and strategies needed for the next steps in human space exploration. The legacy of Voyager's discoveries is embedded in these current missions, from robotic probes to future human expeditions that might push even further into the unknown. SpaceX's Starship, which aims to make human travel to Mars a reality, will require advancements in propulsion, sustainability, and long-duration space travel. The lessons learned from Voyager's mission, such as maintaining communication over long distances and dealing with the limitations of aging technology, will inform the designs of these ambitious new spacecraft. The idea of exploring the solar system and beyond is no longer science fiction. It is becoming a reality thanks to the groundwork laid by missions like Voyager 1. Addressing long-term exploration. Voyager 1's journey is not only about data and discovery, it's also about the future of space exploration. As human missions grow in scope and complexity, the long-term lessons of Voyager's mission must be carefully considered. The most striking feature of the Voyager mission is its longevity. Despite its age and distance from Earth, the spacecraft continues to provide us with valuable data, teaching us that the technology we build today must be designed with an eye to the future. This emphasis on durability and sustainability is a crucial factor in the long-term success of future space missions. The challenges of space travel, communication delays, resource management, and technology maintenance are all magnified in deep space. As we consider sending humans to Mars and beyond, the lessons learned from Voyager 1 will be integral. If we want to send humans on long-duration missions, whether to Mars, the outer planets, or even beyond the solar system, we need to learn from Voyager's journey. The spacecraft's ability to continue transmitting data despite its advanced age and the challenges it faces shows that there is hope for our future deep space ventures. As humanity looks to the stars, Voyager's legacy will be an invaluable resource, providing a blueprint for the types of technologies and systems that will allow future explorers to survive in space for extended periods. Voyager's mission is a profound testament to humanity's capacity for innovation, and though it will eventually lose power and stop transmitting data, its journey through interstellar space will continue, carrying with it the message of human curiosity and exploration. Voyager 1's recent discovery of the magnetic highway marks a major turning point in the history of space exploration. The spacecraft's ability to send back data from the furthest reaches of the solar system proves that even as the technology of the past ages, it can still shape the future. The findings have profound implications for our understanding of the solar system, interstellar space, and the very nature of the universe itself. As we look to the future, the lessons of Voyager 1 will guide us. This mission proves that humanity's quest for knowledge knows no bounds, and the challenges we face in space are merely opportunities for innovation and discovery. Just as Voyager 1 has shown us the vastness of the universe, so too does it show us the potential for continued exploration. Our journey into space has just begun, and the discoveries of today will shape the missions of tomorrow. Voyager 1's mission has not only provided us with extraordinary scientific insights, but it has also sparked widespread public interest in space exploration. As it ventures further into the unknown, it becomes a symbol of human perseverance and curiosity. The spacecraft's legacy is now deeply intertwined with humanity's future aspirations, especially as we aim to break new frontiers beyond the solar system. Its ability to continue transmitting data is an exceptional feat that has captured the imagination of scientists and the general public alike. Voyager's journey encourages a long-term vision for space exploration, one that will take decades or even centuries to fully realize. This mission has set the stage for future interstellar projects, such as the study of exoplanets or even the search for signs of extraterrestrial life. The lessons learned from Voyager 1 will be indispensable for developing the next generation of space missions. For instance, new spacecraft will need advanced propulsion systems capable of traveling faster and more efficiently to reach distant stars. Technologies that enhance communication across vast distances will also be a critical focus. The methods of energy conservation, system durability, and low-maintenance technologies used in the Voyager 1 mission will undoubtedly influence spacecraft design moving forward. One significant realization from Voyager 1's mission is that the universe is far more complex than we ever imagined. The magnetic highway is just one of many phenomena that scientists hope to further explore in future deep space missions. There are countless mysteries in interstellar space that remain unsolved, and every new discovery from Voyager 1 serves as a stepping stone toward answering profound questions about the universe's structure and our place within it. Voyager's success also highlights the importance of international cooperation in space exploration. As space agencies from around the world continue to collaborate on missions, the shared knowledge and expertise contribute to the advancement of science and technology. Future missions will likely rely on a combination of resources and ideas from different nations, amplifying humanity's collective efforts to reach for the stars. Ultimately, Voyager 1 serves as a reminder that while our understanding of the cosmos is still in its infancy, our drive to learn, explore, and expand the boundaries of human knowledge will persist for generations to come. Its discoveries, no matter how distant, are shaping the trajectory of humanity's journey into the vastness of space.